Zero force members.
Okay, did every group say zero force members? Okay, so great. So that's the first thing you want to do. You want to find out what the zero force members are. And there was a sheet in the packet, and there was also something in the textbook about zero force members. So what are the two rules? What's rule one?
Extra jump.
Malcolm?
Two members that meet at one point where there are no external forces acting on it, and the two members are not collinear.
That's right. One joint, two members, no external supports or anything there, no external loads there. Those two members are zero. Okay, so zero force members.
Oh.
And we know there's rule one, which we just described, and then there's rule two. What's rule two? Who wants to tell me your rule two?
A member intersecting a collinear set of vectors that does not
Okay, use the word members, because that's what the word is used in trusses.
So you have two members that are linear, and
That are collinear,
and a third one that is
and a third one that's not collinear.
and it experiences no external forces. Then the one that is not collinear has a joint.
Zero. So you have one joint where two are coming in that are collinear and one's non-collinear, and there's no external loads or supports at that joint. The one that's non-collinear is equal to zero. It's a zero force member. And what could you say about the other two? They equal to each other. Okay, good. So look for zero force members. What other things did you say are important in looking at trusses?
Reactions and supports.
Okay, do the reactions at the support. So if we have a truss, and we have maybe a pin connection here, and then here we have a roller, do we need to find both of them?
It depends on what we're at.
Okay, so Angelina,
Yes.
what were you responding on? Okay, remember there are two different ways of solutions for trusses, right? What are the two solutions? Method of sections, and the other one is method of joints. Right? So in this case, if they want you to find every single member, will you need to find both of these?
Yes.
So if they want you to find every single member, they want you to find the values in every single member, do you need to find the reactions at both supports? Yes. Okay? How about, though, they ask you to find these members? What process would you do?
Method of section.
Probably method of sections. Where would you cut it? You would cut it right here. And then in that case, is it important? Is it required to find both of these joints? I'm sorry. Is it required to find the reactions at both these supports?
No.
No, because if you choose to analyze only the left side, which reactions do you need to get? The left. If you choose to analyze the right side, you need this one. Okay? So, the first thing you want to do is definitely find the zero force members. The second thing you want to do is define which method of analysis you want to do. So remember, whenever we approach statics problems, we're looking at the given information and the find, right? And in the given information, they're going to tell you which members they want you to find. If they ask you for all of them, well, then find the reactions at both supports. But if you're only trying to find some members, you're only going to need to find one side of the reactions of the supports. So step one is to find which are the zero force members. Step two is to figure out what method of analysis you want to do. And then step three is to do a free body diagram of the whole structure.
Of the whole structure, or?
Yeah, the whole Because if you're gonna good question, if you're gonna section this off, you need to know A already, right? So this is joint A, and this is joint B. If you're gonna, even if you section off, if we section it off here, how many members do I need to find? 3 members. Everybody great? If I say this, this, and this, I need to find 3 members. Is this a 2D or a 3D problem? 2D. How many equations can I get from a 2D? 3 equations. So I can find these 3, but I already need to know this one. Right? I already need to know this one. So let's just write this over here instead. So 3 would be, draw a free body diagram of the whole structure to find the reactions at supports. And I'm putting a parenthesis here with an S. Because if you have to find, if you need to calculate the loading in every single member, will you need to know both A and B? Is everybody with me? If you need, if the problem asks you to find the value in each one of these members, do you need to find A and B?
No, just A, just.
If you need all the members, if you have to find all the members, you need A and B. Okay? So regardless of which method you're going to use, you are going to need to analyze the whole structure and find the reactions at, I wrote, you know what this means, either support or supports. Because if you choose the method of sections, you only need to find the reactions at one side. If you're doing method of joints, you're going to have to find it at both. Okay? So, number 1, you find which of the 0 force members using rule 1 or 2. Number 2, based on what they want to find, you're going to either choose to do method of sections or method of joints. Number 3, depending on which method of analysis you're going to do, you're going to need to draw a free body diagram of the whole structure and find the reactions at one or both of the supports. And then 4, now what are you going to draw a free body diagram of? Let's say you're doing sections. What are you going to draw a free body diagram of?
That section.
A section. So a free body diagram of one side of truss. And then you're going to find the forces in each member. In the members. If you're doing method of joints, what are you going to do? What are your free body diagrams going to look like?
Each joint.
Each joint. Okay. Yeah.
Do we need, obviously we do, just a reminder, if it's negative, report it as
Yep,
compression?
so that's the next step. So 5, after you get the values, you have to report them as either tension or compression. Everybody heard that, right? The last step is every single member value that you got, you have to report them as either tension or compression. So, if I decide to do method of sections, and I draw my forces like this, and I have an AY and an AX here, and I already found these values. If I analyze by drawing the forces away, if I get a positive, is it tension or compression?
Tension.
Tension. And a negative is compression. So I would suggest that you always draw them away. And even if you did method of joints, if you have AY and you have AX, whatever way you calculated it, and then you have this one drawn away and this one drawn away, again, you drew them in tension or compression. You drew them in tension. So if you get a positive, it's tension. If you got a negative, it's compression. Remember, if there's a whole bunch of rope pulling me, I'm the body you're analyzing, and tension always goes away from the body. So when you analyze this body and you're drawing forces away, it's tension. If you're analyzing this body, this point, and you're drawing forces away, it's tension. So if you get a positive, it's tension. If you get a negative, it's compression. Matt?
If we were to use method of joints and I found a force in from one joint that's found in another, and let's say I calculated it using the first joint and it was compression.
Right.
Then if, let's say, okay, I move on to the next joint, would I draw that force that I found to be compression as compression, or would I still draw it as tension?
Okay, so the way this is drawn with no external force, you know this one's going to be 0, right? Isn't that satisfied? This joint here satisfies rule 2.
Mm-hmm.
3 members coming in, 2 collinear, 1 not collinear, no external loads or forces here, that's 0. So let's look at this. Let's call this point C. So I just drew A to C. And let's say my value for A to C was equal to a negative 100 pounds. Okay? So now when I draw point C, I'm going to draw point C, and I'm going to have, I'm always drawing things away. So because I drew it going in this direction, and I got a negative, I'm still going to draw it the same way, because I don't want to have to keep replacing negatives and positives. I'll mess up. So at point A, I drew it this way, so at point C, I got to draw it that way. Right, whatever this happens to be. I got a negative value here, which means this value is equal to a negative 100. So let's call this point D. So at point A, is everybody comfortable? At point A, I will already know AX and AY. So at point A, I drew these guys away because I always want to draw them in tension. But in the end, I got a value of AC of negative 100. Now I go to joint C. I go to joint C and I draw AC going that way because I drew it this way, I'm drawing it that way. And I'm going to draw CD going that way. Okay? So I do sum of the forces in the X equal negative AC plus CD equals 0, and CD is going to be equal to AC, correct? Did I do all my math, my signs correctly? So sum of the forces in the X for this free body diagram right here. AC is negative. Sum of the forces in the X is minus AC, and I'm putting a negative in because it's going in the negative direction. Plus CD equals 0. CD is equal to AC. But AC is equal to a negative 100. So CD is equal to a negative 100 pounds. Got it? So I'm substituting in the value here. Everybody okay with that? Okay. Alex, you had a question. Is it the same question?
Oh, I was just wondering, you know how you said that there's 0 forces to that one and you took away that.
Yeah, I guess I could.
Would be-
I could draw it here if I want, and I'm just going to write that it's 0. Let's call this E. So this is CE at 0.
But like we would still want that if there was vehicles passing by, right?
Say that again?
If there was vehicles passing by, we would still want that beam, right? Like we know that it's 0 force right there, but like if a car passes by there, wouldn't that be joined buckle?
It could have a value, but it's going to be minimal. Okay? But you'll get to more advanced things like that later on. Okay? Any other questions with trusses? Everybody got it? First, find the 0 force members. Then determine which way you're going to analyze the problem based on what they want to find. Then you're going to analyze the whole structure and you're going to find the reactions at both supports or only one. Then you're going to do the analysis. If you choose section, you need to draw a free body diagram of one side of the truss. If it's for joints, you're going to do a ton of free body diagrams for each joint. And then the last thing you have to say whether it's tension or compression. Okay, let's go to the next one now. Okay, frames. So I don't know if Did you all finish the discussion on frames already? No. So let's have your group discuss frames. And if you already have, think now of what I was looking for trusses. What is the method of solution, step by step? Do that for frames. So David's joining you guys.
Yeah, so same.
Daniel. David.
So like, same idea. A lot of money that you want to identify supports. Yeah, but you need to know what the and I think that's the other one that it's then we really only have to find.
This year, ignore the moment.
Still need to know what the supports come out. So we do all the free block diagram. Yeah.
Are you guys okay? You look like you're all sitting in a bar.
I actually heard about this.
Because we have to share all the
It's so confusing to you.
So,
Attach it.
well, it's
It's super fun.
Arthur, are you doing this work right here? Okay.
My strategy was
And you guys have 5 people already.
is that one like you have a bunch of the that much and how to take care of it?
Yeah.
This is fine. Join this first.
I mean integrated
It only shows up though, it's not going to show up if there's
these are all the display should do later.
what that does, if there's like 3 I think, or more, then it's there's going to be
Truss,
extra
right.
forces that should be accounted for other things coming in. There's just 2. Yeah, it's not
and I realized bodies are still it's just actual force reactions. Right? It's only when you take it from that they are seeing. It's like
because
down
other
and
just
you
don't
have to
if they're
you cancel out below.
Is there anything weird about frames? I feel like the trusses from the
And then you're safer with us.
Yeah, see, these are all the same. Yeah.
So in that case,
Right, so you have a supporter, and then you have a member, and then another member. So yeah, it's like that.
but you wouldn't draw it like here. These are
I feel like it's an end.
separated.
Yeah. Like you said, you don't have to worry about it if it's 3. I don't know why there's 4, but if there's 3, yeah, well, it's a pain and then 2 members. Yeah.
3 force. You can have many things attached to either end of a 2 force umbrella.
No, trusses suck. I mean, the frames kind of suck too, but at least...
Like bus
Okay, we're at Team Truss, so Team Truss.
No trust.
No trust. Oh, from a small C, a mighty trust.
Okay, is everybody ready to talk the frames?
Sure.
Any group still talking about the frames? No? Okay. Okay, so frames. So how do we know a problem is a frame problem and not a truss problem? It has at least one 3/4 member. Okay? So we know that trusses are all what? All the members are? 2/4 members. And what do we know about 2/4 members? How do you know it's a 2/4 member?
2 forces.
There are only connections or external loads at the ends, right? So maybe we should write that up here. For trusses, a truss has all 2/4 members. Which means that in a member, It is only at the ends that the forces have connections or external loads. So everything is concentrated on the ends. So a frame has at least one, I don't want to say a 3/4 member because it could have a 4/4 member. It has at least one,
Greater than 2 force members.
yeah,
One member that has more than 2 force on it.
2 plus
it
N.
has at least one member, yeah, with forces not concentrated on ends. How's that? At least one member with forces or connections not concentrated on the ends. Okay, so when we look at this, some of these problems right here. Of these two problems, are there any 2 force members here?
Yes.
Yes,
Which one?
the one on the top right.
Okay, give me a label. You know how to label members. What are they? Problem number what, and what is the name of the member?
1277 BC.
Okay, problem number 677 and AC is a 2 force member. Is there another 2 force member? There is. It looks weird, but it is. Matt?
Problem 6-75, member CB.
Yes. Notice the member curves, right? But there are no external loads or, so what could they have done here? This really didn't have to be like that. I'll just draw it here. So the problem, this did not have to be here. They could have just had a straight piece. Why did they do this? Well, maybe it was free and it was in the garage.
Maybe something has to go through that space.
Say it again?
Maybe something has to go through that space, like a HVAC ducting or something.
Ah, good point. Maybe there's something physical that has to be put in here that we don't see, so they needed the space here. Good point. I like your answer better than mine. But this could have been replaced with that if there wasn't any physical limitation or money issue. Okay? So what does that mean when you have a 2 force member? When you have a 2 force member, what is the loading like? We maybe could have talked about this when we did trusses, but what is the loading like?
Tension.
If this is, let's say, a pin here, and this is a pin here, ordinarily what would we do? We would put an AX and AY and a BX and BY. We would put 4 unknowns. But what do we know? Because it's a 2 force member, the forces have to go through the center. So it's either going to be like this, right? Or it's going to be the other way. So let's say this is AB. We originally would have said, oh, there's a pin here, and this is A, and this is B. Well, we must have an AX and an AY and a BX and a BY, which is how many unknowns? 4 unknowns, which is a lot of unknowns. And the fact now that we know it's a 2 force member, it becomes force AB, and this is AB. So now how many unknowns do I have? I only have 1 unknown. Okay, so it simplifies the problem. Okay? Okay, so what are some other things? So far we said for frames, there's at least one member that is not a 2 force member, right? And then we also know that when there are 2 force members, it simplifies the problem. Instead of being 4 unknowns, it's only 2 unknowns. And that certainly helped us when we did trusses, and that's why we covered frames first, and then trusses in the class. What other things? So what else should we do? What's the order of operation, or what are some other things you want to do? Okay, Charlie?
Set a table?
Yeah, well, in both cases, we would have to do that anyway, right? So, good point. On the exam, I will tell you whether you need to do the given and the find, setting up the table. Okay? All right. Matt?
Decide which free body diagrams you want to draw.
Which free body diagrams? And do you remember when we did frames, we talked about which free body diagrams were typically the most helpful? The whole diagram, the whole structure. So which free body diagrams? And we typically said the whole structure. Was one that was typically good, and what was another one that was typically good? What?
The one that has what you're trying to find.
Right. So for the find information, they tell you, which forces you need to find, and we typically drew a free body diagram of the member that had the forces in it. Right? When we first started doing frames, I had you draw the free body diagrams of everything, right? So in case of this one, I would have had you draw, what would have been the first free body diagram I would have had you draw? You take the whole structure and remove it from its main support. So you would have had an A, B, C, and you would have drawn a free body diagram. Then what else would we have done? A free body diagram of each member. We drew one of AB and then one of BC. Well, let's see. It says determine the horizontal and vertical components of the things in A and C. So you're going to need to find what's in here. How many unknowns are in A? 2. AX and AY. How many unknowns are in C?
2.
Think about what we just said.
Oh, 1.
There's only one. It's a 2 force member, right? And since this could be replaced with this, I'm not going to draw it, but the force is going in the direction it goes. This is a little bit weird, right? Even though the member goes B down and then over to C, the axial load goes right through this, so it goes through here. So for C, you would have a BC this way and a BC that way. So with this whole structure, you have an AX and AY, and you have a CB. How many unknowns do you have? 3 unknowns. What do they want us to find? They want us only to find the forces in A and C, and it's 3. How many free body diagrams do you need?
1.
1. Let's do it again. The question asks for us to find the horizontal and vertical components of the forces in pin A and C, which they're actually asking you for. What are the reactions at A? What are the reactions at C? A, you're telling me because this is not a 2 force member, there's an AX and AY because it's a pin. This is a 2 force member, which means the loading goes straight from C to B, which is 1 unknown. So we have a total of 3 unknowns. It's a 2D problem. How many free body diagrams do you need? 1. Matt.
Going back to one of the examples that we worked through in class,
Yeah.
if we were to first draw the free body diagram of the whole structure, and then, just for the sake of argument, we draw the free body diagram of member ABC without the connections, would you have like an AY prime and an AX prime sort of situation? You know what I'm talking about?
Yeah, no, that wouldn't be, because the only time we had an AX and the only time we introduced the prime is when there were 3 things coming together.
3 things, okay.
Actually, 2 things and the connection to the wall.
Okay.
So in that problem that we had, here's the wall, and there was something here and something here. And when you remove one thing, you have to account for it, and we had an AX and AY. And then when you remove the next one, you had to have an AX and AY prime. Here, there is only one member connecting to here. here there's only one member connecting to here. It's one disengaged member, so there's no prime.
Okay.
Same thing here, it's fine for me.
Okay.
Here, how about this one? So at point E, we have three things coming together, the support itself, and then ED and EB. So when you remove the whole structure away, you just have an EX and EY.
Correct.
And then when you separate these two, you'll have an EX and EY prime. But I'm not going to give you a prime problem. Okay? So what if we look at this problem? Let's see what it says. Determine the horizontal and vertical components of the forces in A, B, and C, and D. They want you to find everything. So at A, how many unknowns are there? Look
One.
at it close.
2.
Normally you would say there's an AX and an AY, but what can you say about AC?
1.
It's a two-force member, so there's only an AC going this way or going that way. So there's only one unknown at A. How about at B? How many unknowns? 2, a BX and BY. What about at C? There's one unknown, and actually it's the same one as this one, right? So far, how many unknowns do we have? 3. A BX and BY and an AC. 3 unknowns. But then there's something going on here. What's going on here? What's the name? What kind of support is it? Fixed support, which means we have what? 3 unknowns. We have a DX, DY, and a moment. So we're going to have 6 unknowns. So we're going to need at least 2 free body diagrams, right? So what would your first suggestion be? Let's see. What are we saying here? For frames, typically, we're going to do the whole structure. And if you took the whole structure away from D, can you find all the reactions at D? Why, Tim?
Because all the other stuff is internalized.
It's all internal, so the only thing external is dx, dy, and the moment, which is 3 unknowns. Can you find 3 unknowns with one free body diagram? Yes. So you take this whole structure away and you solve for dx, dy, and the moment about D. Then the question is, then what do you do? Well, you have, it's a pin there, right? What is this? I guess we don't have a letter here. So E, this member, we have the option of doing that member, or this member. So talk to you guys, talk to your group. What would you do? We have 3 unknowns left. We have we have AC, and we have BX and BY. What do you want to do? Talk to your group.
And we only need one more.
You have AC, you need to find AC, and you need to find BX and BY. What free body diagram do you want to draw? Or which free body diagrams do you want to draw?
Do use BCD. BCD. BCD.
I don't need to improve the body diagram for
It's good memory. Sit on your bed. Yeah. My voice utilities, yeah.
No.
But the price of living is saying
I was gonna say if we do that top one, then we immediately have
Okay, what are the choices? Your group, what did you guys want to do? Or maybe you didn't do it as a group, but you thought of it individually. Kenzie, do you have an idea what you want to do? And there's lots of options.
What matters?
Okay, shh. Yeah.
we would do a free-body diagram of either the end point.
Okay, B here, so you would do a free body diagram of that,
Or a free-body diagram of BCD.
or a free body diagram of B, C, D. Yeah? So either one. And so when you looked at this number, how many unknowns were there? How many unknowns were in this number? 3. Bx and by and the AC. Right? And if you only did this number, how many unknowns are there?
3.
3. Bx and by and the AC again. So whether you did this number or this number, you have one member with 3 unknowns and you need 3 equations. Yeah. Everybody got it? If you want, you can do it with 2 different drawings. You could draw this free body diagram and do some of the moments about B. You already have D. And you could find C. And then you could take this and do some of the moments about A and find BY. And you'd have to do some of the forces in the X. But I probably would just do one more free body diagram. And do either A, whatever the horizontal member is, or BCD. Alex?
What about that ping piece of metal right there? What if we do like some of the moments and forces?
Okay, say it again. Which free body diagram of what?
It doesn't really have a label.
Okay.
But that was cool. What if we do like?
Just this member.
No, the whole thing, but you focus on that. You focus on the triangle and you do some of the moments, and then you're able to find AC and BX and B1.
Okay, tell me what you would draw. What would you draw on your free body diagram?
Just that.
The horizontal member. Okay, and
AC.
And you would draw AC separate or
yes.
together?
Together.
Okay, so here is AC. And so what would I have? What would be on my free body diagram for this, everybody? I would have BX and BY, right? And then I would have my AC, drawn whichever way you want it, which way. And then you would have the external loads, right? What is that, 2 kips? 2
kilonewtons.
2 kilonewtons, 2 kilonewtons. Of course, remember to put distances, right? Remember to put distances on your free body diagram and axes. But is this what you're saying, Alex?
Yes.
So yeah, you could draw a free body diagram of these 2, but I don't know if this is any better than just drawing it. This is really the same thing as drawing without that. It's really the same, right? Because it's transmitted through.
And then we just focus on the forces in the one direction.
And then you could do a sum of the forces. You can't do sum of the forces in the Y, because some of the well, you can, but the best thing is always to do which equations first. Pick an equation with one unknown. If you did sum of the forces in the Y, BY is an unknown and ACY is an unknown. So I wouldn't do that. I would do sum of the moments. So what equation would you want to do here first? Everybody think about that.
Some of the forces in the X.
Okay, sum of the moments, I hear about A equals 0, and what would you find? BY. Right, sum of the moments about A, BX goes right through A, the only thing you're going to find is BY. Then what would you do? Sum of the forces in the Y equals 0, and you would find what? AC. And then you would do what? Sum of the forces in the X equals 0, and what would you find? BX. So on frame problems, typically you are going to do a free body diagram of the whole structure and then a free body diagram of whichever member the forces are in. And minimize it. Any questions on frames? Angelina?
On On the test, are you gonna ask us to find an unknown for these conversations?
Say it again? No, no, you mean, am I gonna ask you for doing something efficiently? Yeah, no, I won't, but you should. Because the more work you do, the more chances of error. So you should find, first, try to see if there's an equation with only one unknown. You're best at math in adding and subtracting and multiplying. Okay, next. So the next type of problem is shear and bending moment diagrams. Have you guys talked about it already? No? Okay. So in shear and bending moment diagrams, the first thing that's given is it shows you what the loading is. So from point A to point B, they show you where all the external loads are. But they give you some kind of connections at the ends. So what's the first thing to talk about? What would your order of operations be?